Totally, huh? So it's just you. Okay, we're being recorded.
Really?
Yeah.
Okay, now?
Like right now. Okay. All right, welcome everybody. So this is the metric system. I'm actually gonna skip ahead. I'm not gonna read all this stuff to you. I expect you to do that on your own. But I will walk through this lab with you guys. One of the background things that, hey, you gotta not be distracting because these guys are trying to learn too, okay? All right. So in the background, they talked about the imperial system, and the imperial system is like everything. Like I'm talking to you, Ryder, too. So the imperial system is things like inches. Have you heard of an inch before? Have you heard of a mile? Like running a mile? Oh yeah. Okay. How about something being like scooped out in like cups, like a cup of flour, a cup of sugar? Okay. What about like a gallon of gasoline? Have you heard of that? Like I need to put a gallon of fuel in my car. Yeah. Oh, that's a thumbs up? No? You don't know what a gallon is? Okay. Well, you guys, I'm sure, have heard of gallons. So all of those are imperial units, and to convert from one to another is a pain in the butt. I've lost my sidekick already. I guess we're not. Are you gonna do this with us? Okay. Okay. So, all right. Well, it's right here, bud. Screw it. There you go. All right. So those are the imperial system. That's like gallons, cups, miles, inches, feet, yards, that sort of thing. Pounds, right? How much you weigh in pounds. And it's really tricky to convert between them because, dividing something like a mile by 5,280 is a pain in the butt, or converting from even the imperial system to the metric system is a pain in the butt. Like 2.54 centimeters are in 1 inch. It's not a very easy conversion. But what is easy is the metric system. And so if we all agree that a certain unit of length can be called something, and that 10 of those can be called something else, and 10 of those, 3, 4, 5, 6, 7, 8, 9, 10 can be called something else, and 10 of those can be called something else, if we can all agree on that, then it's easy to convert, because then you're just dividing by 10 or multiplying by 10. So this is kind of a fun activity, right? Or you haven't even started multiplication yet.
No.
But if you have a number, like the number 1, and you multiply 1, and you multiply 1 by 10, all you have to do is add a 0. Watch this. I multiplied 1 by 10, and now I have 10. Crazy, right? And what happens if I multiply 10 by 10? What's 10 times? So 10, 20, 30, 40, 50, 60, 70, 80, 90.
100.
So yeah, so 10 tens is 100. So if I multiply 10 by 10, 10 times 10, I just add another 0. And look what I get.
100.
Yeah, and then guess what happens? If I multiply 100 by 10, if I have 10 100s, guess how many I have? I just add another 0. Look, I'm multiplying 100 by 10, and how many do I get?
A billion.
That's 1,000. You get 1,000. Yep. All right, so that's why the metric system is so easy to convert back and forth, because the units are all multiples of 10 of each other. And so some of the abbreviations that you guys will see, actually, I'm getting ahead of myself. Why this is important should come first, then you'll pay attention. So the reason this is important is that why we're doing this lab, why we're doing an estimation and then like a measurement, is so that you get an idea of what metric units look like. And so if you know how much 5 cc's looks like, then if you're going to be a nurse practitioner or a nurse in a hospital and the doctor hands you a syringe that should have 5 cc's in it, but it only has 0.5 cc's in it, we want you to be able to recognize the difference right away, because it could mean life or death. And so that's why we do these sorts of things. I love this statement here right before all this, is remember that medical errors killed more people last year than all accidents combined. Only cancer and cardiovascular disease actually surpassed it. It would have been nice to have a source. I just copied this from the lab manual, so I believe it, because the guy is a scientist. That sounds terrible. Like taught not to do that. What is that? Appeal to authority for you logicians out there. Okay, so anyways, you ever hear doctors and blah blah blah? Okay, prefixes. So these are some of the units that you guys will hear a lot in science. One of them is kilo, like kilograms. Usually we give body weight in kilograms. So 1,000 grams is a kilogram. So you multiply 1 gram by 1,000 and you get a kilogram. Centi. So centi is like 1/100th of something. So a century is made up of 100 divisible or indivisible units called years. And we say, sorry, I was saying indivisible, but it's made up of 100 units that are called years, and that's a century. Or if you have 1,000 years all lined up, we would call that a millennium, and that would be a 10 to the third power difference between the gram and like the kilogram, or the milligram and the gram. Excuse me. So milli, we're talking about 1,000 parts make up the whole. So when we say a milligram, we're talking about the meter, or a millimeter. We're talking about the meter being broke up into 1,000 pieces. Okay, this is super distracting. I'm sorry, I'm having a hard time. I'm gonna pause it. I'm gonna kick this kid out because he's distracting me. Sorry. So that was a little distracting. So anyways, the idea is that if we can all agree what the base unit is, like how long a meter is, or how much a gram weighs, or how much volume a liter is, if we can all agree on those, then we can divide those units up by orders of 10. So we can take a gram and divide it into 10 parts, or we can take a liter and divide it into 1,000 parts and make a milliliter. And so that's the idea. And so you're going to see a lot of that as we go through here. Now, I'm on page 4 at the top. We'll get into micrometers. And so micrometers are just like millimeters, but they're the next level down. So a millimeter is super tiny. Divide that up into 1,000 pieces, and one of those pieces is a micrometer. And so if you have 1,000 micrometers, you'll have a millimeter. And so on, nano, pico. I mean, it's like, it gets mind-boggling when you get that small. Okay, so we want to familiarize you guys with the metric system. Let's make sure that we have our balance. You have a 100 milliliter cylinder, and then we have our paper tape measure. So in the instructions, if you're doing this before I change it, it says get your 3-meter metric tape measure. We don't have those, but we'll work with this. Okay. All right. So what we need to do is we need to estimate, or guess as best we can, the size of certain objects. And the objects that we need to guess are a penny, your shoe, a coffee table. I'm going to use this one. Your hand, and then the tip of a pen or pencil, like this. Okay. So the first thing we're going to do is let's just estimate what those lengths might be. Now flip your tape measure over to where it's the smaller divided units. So one side's gonna have like the numbers going slow from 1, 2, 3. The next side, they're gonna be squished closer together. That's the side that the metric side is. And so each one of these units is a centimeter. Stand by. All right, so if you take that tape measure and you look at the tick mark that starts it, and then all the way up to where the 1 is, you'll notice that there's 10 tiny ticks. It's alliteration. Sounds like I'm doing poetry. There's 10 tiny ticks on this tape. So from 0 to 1, there's 10. And one of those little ticks is a millimeter. So now it wants us to estimate, okay, how big might a penny be? Well, you take the guess, you write it down. I'm going to measure a quarter, so you cannot copy my answers for this one. Okay. I think the quarter is like 25 centimeters. Or not 25, 25 millimeters. 25 millimeters. 25 of those little tick marks. All right, so Ryder's back and he's going to help us estimate sizes. So Ryder, look at this. This is our tape measure. I've already guessed what size I think this quarter will be, but now we need to do our shoe. How big do you think this shoe is, Ryder? Without holding the tape measure up. Just look at that and then look at the tape measure. And you guys can do this too. Get your shoe out. I'm only gonna do like 3 objects, and then you guys can pause it and do the rest. What do you think?
Hang on, let me see. What about 30?
30, he says. Let's see how close he is when we get there. All right, so we're gonna guess the coffee table, but then I want you guys to guess your hand and the tip of the pencil. Okay. All right. How big do you think this coffee table is, Ryder?
40.
Wow, that was quick. Okay. So go ahead and pause it, you guys, and then you take and estimate the other ones, and then unpause it when you're ready to actually measure them. Okay, welcome back. What we're gonna do is now we're gonna measure the object. So measure your penny. So what you're gonna do is place your penny on top of your tape measure. You will hold one edge to the line that is designated by no 0, but it is 0. And then you will measure the diameter across it. And it comes out on mine to 2.5 centimeters, which is the same as 25 millimeters. That was a good guess. 25, and it's 25 cents. Coincidence? I think not. All right, let's do our shoe. So Ryder, I need you to read this number for me. We're gonna put the heel on the 0 tick mark, stretch it out, and then how long is our shoe, would you say?
30, right?
30?
Yeah, look, the 30 is right there. And it's
I'd say it's 30. I'd say it's 30.5. Because it's almost a 30. It's halfway between 30 and 30.
Mhm.
So I would say 30.5. Wow, you were close. You're only half a centimeter off. Or none at all if you round down. Okay, coffee table length. Let's see how wide our coffee table is. This one I'm gonna have to put the tape measure on top of the coffee table. Hold the tick mark on one edge. How wide is it, right?
looks like 40.
I'll bet this was made and assembled in a country that uses metric system. 40. Wow, we are very accurate here. Go ahead and finish measuring your stuff, guys, and we will meet you back for mass and weight. All right, guys, welcome back. We are now going to switch over to our mini scale. And so this thing is pretty cool for coming in a cheap lab kit. We'll turn it on. And it says hi, and then it says 0.0. Now mine is set for grams. Make sure yours is also set for grams, or you're going to be really confused by why we have totally different measurements. Okay, grams is a standard unit of measure. A gram, we should have done volume first, because gram is actually 1 milliliter of water. So if you fill this thing, watch, Ryder, if you fill this thing up to here, to that line with water, that is exactly 1 gram. That's how much it weighs.
What happens if it's like right there?
It'd probably be more than a gram if it was up there. So that's 1 gram. And so now now that we have a standardized unit for mass, we're gonna say, okay, how much do you think a penny weighs? Well, how much do you think a penny weighs, Ryder? Well, they're gonna do penny, we're gonna do quarter, so our answer is gonna be a little different. How many grams do you think this weighs?
Maybe 80.
80 grams. That's a good guess for that quarter. All right, how about this pen? How much do you think this pen weighs? Do you think it weighs more or less than the quarter?
Maybe 25.
25, okay. And then a paper clip. How much do you think this thing weighs?
25.
25 as well. All right, I'm gonna stop there. Go ahead and take the rest of you guys' estimates. I'm gonna pause the video, and then when we unpause it, we'll actually measure them and see how close we were. All right, Ryder, go ahead and put that. We're gonna weigh our stuff. You guys weigh your penny. Ryder, go ahead and weigh our quarter. See how much it weighs. See how close we were. What does that number say?
5 and a 6. 5.6.
5.6. Oh my gosh, we were way off. We thought it was 80 grams. If you had a pocket full of quarters, your pants would fall off if they weighed 80 grams. Okay. But they don't, thank goodness. They're only 5.6 grams. All right. Now we need to take that off and measure the pen. So can you take the quarter off, Ryder? And can you measure this pen? What does that say?
8.6.
8.6 grams. Whew. We way overestimated that. We thought it was going to be 25, but it was only 8.6. How about this paper clip? Can you put that on the scale and tell me what that weighs?
Yeah. 3.9.
3.9. All right, now you guys pause the video. Put a slice of bread on there, tube of toothpaste, and 10 mils of water. And you might be like, how am I going to put 10 mils of water on there? So let's actually do that one together. Hopefully you estimated it. I think 10 mils of water is going to weigh 10 grams. That's what I think. We'll see. So I take my graduated cylinder, I put it on top. You can do it this way, or there's plenty of other ways to do it too. But this way, I'm going to zero it so it says that it's 0 weight. And then I got to figure out how I'm going to add water to this without spilling it. So I'm going to use my Dixie cup. I'm going to put some water in here. And I'm just going to pour it in until it gets to 10. Is it at 10 yet?
No, it doesn't look like it.
Oh my gosh, put too much in there. Take a little tiny bead out. Put that back on my scale. I'm going to have to use my transfer pipette to get the right amount of water in. So I'm going to use a transfer pipette to add water until the bottom of the meniscus is touching that bottom line on my graduated cylinder. So I got a little bit more. There we go. Boom. All right. So the bottom of my meniscus, that's the little U-shaped curvature of the water column inside of the graduated cylinder.
It's 1.00.
All right. So tell me, Ryder, what does 10 mils of water weigh?
1 and a 0 and a point and a 0.
So it sounds like 10.0 to me. Is that right? Well, look at that. I'll be darned. Was I cheating? Possibly. But I swear the meniscus and the bottom of the meniscus is on that line. So whatever. Okay. Moving on. We're going to do volume next. All right, we're back and we're ready to do our volumetric estimations. Now, don't forget that they're in the instructions themselves. They ask you to take a selfie of yourself measuring your coffee table. Yeah, and that gets uploaded too. You'll take a picture of the table that you're filling out. Then you'll take a picture of you. Oh, what was the second one for mass? Oh, of the water. So this thing that we just did. See, it's still in there. So go ahead and take a picture of you with that. Now that I think about it, that's really dumb because like you could take a picture of it. That doesn't mean you actually used it. What do you think? I think they should still take a picture of it. I want to see a lot of selfies. I want to know what you guys look like. All right, so take a selfie, you measuring the 10 mils of water and how much it weighs. And then also the table for mass. And then we're going to do volume now. So it asks you to get 3 containers. I highly recommend getting smaller containers because if you get a giant container, it's going to take forever to fill it up with your 100 milliliter graduated cylinder. So you want something that's maybe a little over 100 and maybe a little under 100. Okay, so let's do this. My first container, so I want you to write this in too. My first container is going to be a glass mason jar. My second container is a Dixie cup. My third container is a small Tupperware, small glass Tupperware. Okay, so Ryder, this is our transfer pipette. I want to show you guys how much 1 mil of water is. So if we fill it up to that top line where it says 1 mil, that is 1 mil of water, Ryder. Watch this. That's 1 mil. How many of those do you think will fit in this glass?
40.
40? All right, he says 40. See how close we are. All right, how many of these 1 mils, Ryder, do you think fits in here in that glass thing?
How much was it?
Well, look, you can see it. So watch me fill it up to the 1 milliliter mark. I'm gonna dump it in. That's 1 milliliter. How many of those do you think would fill up that glass Tupperware?
50?
He says 50. And then how many do you think would fill up this Dixie cup?
20?
20. Okay, let's find out. So this is where you gotta pay attention, okay? You don't want to fill this up and try to dump it into the 100. I did that the last video and I looked like an idiot. I'm glad I compared. In some ways, maybe I'm glad I messed that video up because that was embarrassing. No, we do not want to end the meeting. Okay. All right. So what you're going to do is you're going to fill this up, the bottom of the meniscus of water, all the way to the 100 milliliter mark. Go ahead and do that. And you can use your transfer pipette to take some out or add some in if you need to. Okay. So I got it over 100. So I'm going to take some out. It shouldn't take that long. And then boom, bottom of the meniscus right there. All right. So I'm going to add this to my jar first, my mason jar. Okay. That was 100. Holy cow, this might take us a while. So you guys can be doing this too while I'm doing it. Okay, there's 200. Oh my gosh, we're only halfway, right? And we got a 200. So definitely be doing this at home while you're waiting for me to do it. There's 300. Oh my gosh, this is gonna have more than 400. Can you believe that? Can you believe it's gonna be more than 400 full?
Dude, that's crazy.
I don't know. What did you say it was gonna be, like 40?
Yeah.
I would say you were a little bit off. What do you think?
Yeah.
Just a little bit?
Yeah.
Okay, that's 400.
Dude, 400.
Now here's a trick, right? Fill it up to the top on the last one, because we'll obviously get there. So we'll fill it up to the top to the 100 mark. Okay? And then, once you've done that, you just pour it into the glass until the glass is full. So tell me when to stop, Ryder.
Stop.
Really? Is it full? I can add more water.
Stop.
Okay, right there. Woo! And there's only 10 mils left. So that was 490 milliliters that jar was. Oh my gosh. Okay, I hope we didn't pick one that big for the other ones. All right, so you can dump that out and then we'll start on the next one. Be very gentle. I'm gonna spill this all over the counter. Oh, good. I don't care if it drips on the floor. I just don't want to lose it on the camera. All right, so that's our first object. Let's test our Dixie cup next. I'll get rid of the water that's in there already. And then we'll just fill this up to 100. We'll use our transfer pipette. Where'd that go? To get it right to 100. Yeah, maybe I'm not being super duper accurate, but we'll be close enough to know how good our estimate was. Right about, when should I stop? Right now? Okay.
Mm-hmm.
Dang. So there's only 15 left. That means the Dixie cup had 85 milliliters in it because there's still 15 in the thing. So I filled it up to 100. There's 15 left. That means I used up 85. Okay, now let's do a small glass Tupperware. Get rid of the Dixie cup. And then now we got our small glass Tupperware. And Ryder, you said that one was going to be like... How much did you say this was going to be? You want to try? You want to guess one? You want to guess one more time?
Yeah.
You said 50, but the Dixie cup was 85, and that other one was 490. So how big do you think that one's gonna be?
Maybe just like 400.
400 is a good guess. All right, so we're gonna change our estimate now that we've played around a little bit. 400. Okay. Blah, 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 blah. That's 100. So it fit 100. That's good. That was 100. This should be. Oh my gosh, is it gonna spill? No, 200. All right. And finally, this one we won't use all of it. And tell me when to stop.
Stop.
Really?
Yes,
No way. I can still add more.
and stop.
There. Okay. I've got 55 left, so that means I used up 45. So that was how many? 245. So I think you were still closest with the Dixie cup because you were over 400 off the first one. You were only 60 off at the second one, and then you were like about 150 off the third one. So, all right, you guys. So that's all volume. I'm gonna pause it, and then we'll come back and talk about the converting units and stuff like that. Okay. Okay. Welcome. All right, I'm gonna do the best I can. I think we've got good volume. I think everything should be good. If this sucks, I won't know it until I get ready to post it. But I think I can see myself. I can see my number line, and then I can also see that my voice is coming through. I might turn that up a little bit, actually. Okay. All right. So I'm on the converting. If you're doing conversions, so I'm on the converting part. Basically, like I said before, units of mass, units of volume, and units of length all have a standardized measurement for their like individual units. And so gram is, the mass, liter is for volume, and meter is for length. So the first thing that we're going to do is we're going to convert units of length. And so I have here, I drew the number line across the top. That's like the one in your book. The only difference is, did I draw that backward? I drew U. It's supposed to be mu. There we go. Which is micro. And then we have nanometers. Oops, nano. My bad. Nano. Okay. And that's as far as we'll go. So the first question, and I'll do the first four, and then I'm gonna let you guys do the next four as we skip through this. So the first one is 4 millimeters, and it's wondering how many centimeters that might be, right? And so what we can do is we can look up here and say, okay, I've got 4 of these. How many centimeters is that? So here's a meter. 1/100th of a meter is a centimeter. Okay, so if I have 4 millimeters, how many centimeters is that? Well, I know that it's going to be less than 1 centimeter. It's going to be way less than 1 centimeter. It's going to be like, yeah, be like less than half of 1 centimeter. Because remember, if I took this and I divided a centimeter into 10 parts, then I would have a millimeter. And so 10 millimeters equals a centimeter. All right, so anyways, if 10 millimeters equals a centimeter, then 4 millimeters would be like close to almost half of 1 centimeter. So at least I kind of have an idea of what to expect once I do the conversion. So here's how I do the conversions, and this is really simple. So I take the units I want to go to, and that's the first thing that I multiply it by. So I go, okay, I'm in millimeters. And we can do it like this, right? So we put the numerator over the denominator. And I'm going to change the units. And so I'll put a little bracket in parentheses here. And this is how I'm going to change the units. So I'm going to say, all right, I want to get to centimeters. I want to get rid of millimeters. And so what's going to happen is the millimeters will cancel out, and I'll be left with centimeters. And then all I have to do is put my conversion in here. Cool. So what I'm going to do is I'm going to say, all right, there's 10 millimeters in 1 centimeter. And I multiply this through, and I get 4 divided by 10. I should get 0.4 centimeters. And that's the first problem, 0.4 centimeters. Okay, I'm gonna write that in on my paper too. got my pen. The next problem. Hey. All right, I got my trusty pen now. Okay. 0.4. The next problem is nanometers. So I'm gonna erase this. Should get a better font, or it's gonna start looking really gray on the. All right, the next one is nanometers. So I have 7 nanometers, and I'm going to convert that to millimeters. I want that in millimeters. All right, so let's figure this out. Let's just use the steps we talked about just a second ago. So there's 7 nanometers over 1, right? Because I can do that like trick of division where I can cancel units out. And put times, and there's my conversion, and that will give me that answer. Okay, so up here, I want to put the units I want to go to. I want to go to millimeters. And then down here, I'm going to put nanometers, because now the nanometers will cancel out, and I'll be left with millimeters. And then all I got to do is say how many nanometers are in a millimeter. Well, let's take a look at this. There's my nanometer. Holy cow. There's my millimeter. That's like 6 orders of magnitude away. Think about this. There's 1,000 of these in one of these, and there's 1,000 of those in one of those. We're going to have to multiply this thing by like, or divide it by millions, a million. So check this out. So this is how I figure this out. Each one of these tick marks is like a 0 that we're going to divide by. So that's 1, 2, 3, 4, 5. It took me 6 zeros to get there. So it's 1, and then 1, 2, 3, 4, 5, 6. So there's 1 million nanometers in 1 millimeter, which makes sense because if you take a millimeter, divide it into 1,000, take one of those, divide that into 1,000, that is so infinitesimally small that it makes sense that it'd be a million. So what is 7 divided by 1 million? Oh boy, how do we do that fraction? Well, we can do it just like we do scientific notation. So I've got 7. I'm going to give myself some space here. Hopefully we can see that. Yep. It's 7.0. It goes without saying, right? It's 7.0. Now, I did that so I can show you the decimal. If I want to divide by that many zeros, I'm going to move the decimal 6 places to the left. 1, 2, 3, 4, 5, 6. And there's my decimal. And all I was doing was skipping places. So every place I skipped is a 0. That's like dividing by an extra 10. 1, 2, 3, 4, 5. I'll put a 0. So this is actually 0.000007 millimeters. And that makes sense to me because 7 nanometers is tiny. 7 nanometers is 7/1,000,000ths of a millimeter. And so this, of course, this number here makes total sense. Now, there's another way that I could write this, and we're going to talk about this in a little bit, but I could use scientific notation. I could just say, oh my gosh, that's 6 zeros on the bottom. That's a lot to divide by. So what I could do is I could say, well, it's actually going to be 7 times 10 to the minus 6 millimeters. And what I mean by that is I'm saying, okay, it's 7, and it says multiply here, but 10 to the minus 6 power is 1 over 10 with 10 to the minus 6. Or 1 over a million, if you will, right? Because there's 6 zeros there. And so this is how we would write it in scientific notation, and then this is how we would write it into our paper here. So you could do either or. I don't really have a preference. So 0.12345 zeros and a 7. And you might say, wait, there's 6 zeros there. Why is there 5 zeros here? Remember that we had to jump onto the other side of the 7, right? That's one of those places, and then there's 5 zeros. So making that jump from this side, the decimal from this side of the 7 to the other side, that costs us one of those zeros. And so that's why there's still only 5 zeros before it. Okay, hopefully that makes sense. Let's erase that and we'll move on to the next one. I'm actually gonna get a real rag to clean this up with, or we're gonna have a disaster. Okay, I'm back. Next problem is centimeters to millimeters. So we have 34 centimeters, and we're trying to get to that in millimeters. Well, I know that millimeters are smaller than centimeters, and so I'm going to need a lot more millimeters to get that many centimeters. So I know I'm going to have to multiply by a bigger number. Okay, that's my first clue. So let's do our conversion. 34 centimeters over 1 multiplied by some conversion factor equals millimeters, something in millimeters. This conversion factor, I want to put the units I want on the top, and then the units I want to get rid of on the bottom. I want to cross that out. Okay. So we got 34. Now I just need to figure out how many millimeters are in a centimeter. Well, centimeters on bottom, I know that's the bigger number, so there's 1 there, and there's going to be 10 millimeters in 1 centimeter. So 34 times 10, 340. Boom, there you go. Next problem. Let's erase that one. I lost my marker. There it is. Next problem. 61 micrometers into nanometers. Micrometer is bigger than a nanometer, so we're going to need a lot of nanometers. So 61, hopefully you guys can see that. There we go. 61 micrometers is equal to something in nanometers. Okay? Well, let's do our conversion. 61 micrometers times some conversion is equal to something in nanometers. And I know I want nanometers, so I'm going to put that on the top. I want to get rid of micrometers, even though I drew that like an M. There we go. And so those units will cross out. And then I just have to say how many micrometers are, or how many nanometers are in a micrometer. Well, it looks like 10 to the first power, that's 10. 10 to the second power, that's 100. 10 to the third power, that's 1,000. So there's going to be 1,000 nanometers in a micrometer. 1,001. So the answer here, 61,000. Okay, since that's the last one of those problems, I want to turn this into scientific notation. Okay, so 61,000.0 is the same as, watch this, 1, 2, 3, 4. If I move it 4 places to the left, then I get 6.1. And then all I got to do to regain those 4 places is multiply it by 10 to the 4th power. And that is the same answer. So 6.1 times 10 to the 4th power is 61,000. Just like that. Okay, so let's move on to mass. We'll go kilograms to grams. So again, I'm just going to go through the first 4 with you guys. We'll see where we end up at. So WebEx has this annoying thing where if nobody joins your meeting, even though this is how I'm recording this, if no one joins your meeting, it has like a timer that will shut it off. And if you don't catch the timer, it'll turn off your meeting. But it looks like we're okay. All right, so I'm going to start back over at mass, at the kilogram to gram, because that's where I noticed the camera fell off, and I think I should be able to trim and edit the videos and put them together. Okay, so we're at half a kilogram to gram, so 0.5 kilograms, and we want to turn it into grams. Now I know that grams are right here, right? That's the gram, and it takes 10 to the, that's 10 to the 1, 10 to the 2 is 100, 10 to the 3, that's 1,000. So it's going to take 1,000 grams to make 1 kilogram. If I have half a kilogram, I probably have half 1,000. But let's do the math anyway. So 0.5 kilograms over 1 times our conversion is then going to equal grams. I want to get rid of kilograms, so I'm going to put that on the bottom. I want to convert to grams, so I put that on the top. Then I just specify, okay, how many grams are in a kilogram, or which number is bigger? There should be 1,000 grams in 1 kilogram, which equals 500 grams. So that was right. Okay, next problem. That one was pretty easy. Let's do the next one. 7.4 micrograms is equal to, we got to convert that to nanograms. I got micrograms, I got to convert to nanograms. So if I have 7 of these, I probably have like thousands of these, right? So I know that this number will be bigger. Okay, so let's do our conversion. 7.4 nanograms. Do our conversion into nanograms. I didn't give myself a lot of space there. Equals nanograms. Okay. So we want to get rid of micrograms and we want to keep nanograms. So I'm going to cross those out. And then I just need to figure out, okay, how many nanograms are in 1 microgram? It looks like 10 to the 1, 10 to the 2, 10 to the 3. So that's 1,000. There'll be 1,000 of these in one of those, in one of those. Okay, so then I get 7.4 times 1,000 is 7,400. Cool. All right, next problem. Is 3.6 grams to kilograms. And we want to convert that into kilograms. Well, 3.6 grams isn't a whole lot. It's a couple of paper clips, and a kilogram's quite a bit. So I'm guessing we're not going to need very many kilograms to make this. So we're going to need less than 1 kilogram. I know that. So it's going to be 0 point something. And what that number is determined by our conversion. So let's take 3.6 grams over 1, multiply it by our conversion, is equal to something in kilograms. Okay, I know I want to get rid of grams. I know I want to keep kilograms. I know kilograms is the bigger number, so I'm going to put 1 there and figure out how many grams go into that. 10 to the 1, 10 to the 2, 10 to the 3. That's 1,000 grams in 1 kilogram. Cool. So then I'm going to take 1 kilogram, or 1 over 1,000, multiply that by 3.6, or take 3.6 divided by 1,000. So I can do that down here, just kind of on my scratch paper. And if I'm going to divide by 1,000, that's going to be 3 zeros, right? So I'm going to have to go 3 decimal places to the left. 1, 2, 3. There's my decimal, there's my 0, there's my 0. Okay. And then I'll put a 0 on the other side of the decimal to make it look pretty. So then I get 0.0036 kilograms. You might be looking at this and you might say, hold on, you divided by 1,000, why are there only 2 zeros there? Remember that in order to jump on the other side of that figure, I had to divide by 10. And then so that lost me one of the zeros, and then those 2 count for those 2 zeros. Okay, next problem. All right, let's continue on. We just did 3.6 grams. Let's do 8.7 nanograms. So 8.7 micrograms is equal to something milligrams. All right, like I said, let's just do our conversion. Micrograms over 1 multiplied by some conversion is equal to some number of milligrams, right? Okay, good. I see myself. All right, so we got micrograms on the bottom. That's to cancel out. And we want to put milligrams on top. Now we just have to figure out milli to micro, right? Which one's bigger? Milligrams seems bigger. So I'm going to need 1 milligram and talk about how many micrograms are in it. So there's 1, 2, 3. 10 to the 3rd power is 1,000. Okay, and cross out our micrograms. So 8.7 divided by 1,000. I'm going to come down here and do the same thing I did, 8.7. And then we're going to go 3 decimals to the left. 1, 2, 3. That's dividing by 1,000. And that gets me 0.0087 milligrams. Cool? All right, let's go into liters. So volume, you guys can pause that and do the rest in that category. And let's go to volume. So I got 4 milliliters is equal to how many microliters? So I've got milliliters to microliters. Cool. Now let's see if we can do these in our head. We might be able to. Okay, so I have 4 milliliters. I know that's 4 of these is a lot of those. So let's see how many of these is 1 milliliter. I know 10 to the 1, 10 to the 2, so 10 to the 3. So there are 1,000 microliters in 1 milliliter. Well, shoot. And if I have 4 of these, that means I have 4,000 of these. So I have 4,000 microliters. Okay. Let's see the next one. We'll go nanoliters to milliliters. And if you want to pause them and do them on your own, that's fine too. No big deal. So we'll go 7 nanoliters is equal to where was I? Milliliters. So I want to go from nano to milli. Well, shoot, you guys, that's a big jump. 7 nanometers is nothing. That's so minuscule. That's like a couple of water molecules. If you're weighing this, if you're doing this in water, you're wondering how many milliliters that is. Like milliliter is something visible. So something invisible, I'm going to need a lot of that. And so that's going to be a fraction of 1 milliliter. And so what I need to say is, okay, well, how many nanoliters are in 1 milliliter? Well, let's count. 10 to the 1, 10 to the 2, 10 to the 3, 10 to the 4, 10 to the 5, 10 to the 6. There's 1,000,000 nanoliters in 1 milliliter. So that means I need to chop up a milliliter into 1,000,000 pieces and then take 7 of those and represent that in a decimal. So I could do it like this. I could say, okay, we start with 7. We start with 7. And I know I need to chop this into 1,000,000 pieces. So I need to move this decimal 6 places to the left. 1, 2, 3, 4, 5, 6. And I'll put a 0 on the other side of it just for good measure. Okay, and then I'll fill in where the U's are. I'll put a, so we should have, yep. So we've got 1, 2, 3, 4, 5 zeros now between the decimal and the 7, which is good because we were on the other side of the 7. That's where that 6 0 comes from. All right, so that's my answer. 0.000007 milliliters. Okay. Next. Let's do.
Daddy, I already paused it. Like, unpaused it.
I'm sorry, bud. Do you need help? Yeah.
Oh no, it was just the headphones when it hit the unpause button.
Oh, okay, I gotcha. Into milliliters. This will be my last one for this one, and then we'll go into the practice problems. Okay, milliliters to liters. Okay, I'm gonna do this in my head. Milliliter to liter. So I gotta take this. I have a smaller unit. I want to know how many of the bigger unit it is. So that means I'm gonna have to divide by, because now I'm going backwards. So I'm gonna divide by 1,000, right? 10 to the 1, 10 to the 2, 10 to the 3. So I'm dividing by 1,000 to figure out how much of a liter that makes up. So it's basically saying if I took a liter and split it into 1,000 pieces, right? How could I represent 3.8 of those pieces in a fraction or a decimal? And so what I'm going to do is I'm going to take 3.8 and I'm going to go backwards 3 zeros, which is how many are in 1,000. So 1, 2, 3. That's me chopping. That's me chopping it into 1,000 pieces and representing that in a decimal way. So 0.0038 liters. Cool. So that's the conversions there. Now we'll do some practical applications. Don't forget to take pictures of your tables and your charts and your work, because you'll need to submit that on Canvas. All right, so it says the naked eye can see substances as small as 0.2 millimeters. An algae cell is 300 micrometers long. How long is the algae cell in millimeters? And then would you be able to see it with the naked eye? All right, well, let's look. We can only see things that are 0.2 millimeters, 0.2 like that, right? But they're giving us something in micrometers. I need to convert this to millimeters in order to see if it's more or less than 0.2. So what I'll do is I'll say 300 micrometers, multiply it by some conversion is how many millimeters? Well, I want to get the units in millimeters, and I want to get rid of micrometers. So we do that real quick. Then I say, okay, there's 1,000 micrometers in 1 millimeter. So I take 300 and divide it by 1,000, or I take this decimal and I go 1, 2, 3 places to the left. Then I get 0.3 millimeters. Which one is bigger? So I would be able to see that. That's the answer. I would be able to see it with the naked eye. All right, this one's kind of a crazy story, but it's kind of funny. So unless you know Debbie, and then you're like totally shocked at me laughing about that. But I don't know anybody that knows Debbie. But Debbie Lane of Tempe went to Desert Samaritan Hospital and get a radioactive trace of her thyroid. That's something that you would really do. She drank the sample and it moved into her thyroid. The doctor prescribed her a dose of 100 microcuries. But what she got was 100 millicuries. Couple of questions. Which one is stronger? Well, this is what was prescribed. This is what she was given. So she was given something 1,000 times stronger. That's not good. So definitely what she got was stronger. How much stronger was it? Well, how many times do you have to multiply by 10 to get there? So 10 to the 1, 10 to the 2, 10 to the 3. So she got a dose that was 1,000 times stronger than the actual dose. And then what do you think happened to her thyroid? Well, I'll leave that up to your imagination. A doctor, next question, a doctor says you should take 1 gram of cholesterol lowering medication per day. You've heard my spiel on that. Anyways, unfortunately, the pharmacy is out of 1 gram tablets. However, they do have 250 milligram tablets. How many pills would you need to take to get 1 gram per day? Well, we need 1 gram, but we need to know what that equals in milligrams, right? So let's convert. So 1 gram multiplied by some conversion is equal to milligrams. Okay, so I want grams on the bottom, milligrams on the top. I know that 1, 2, 3, it takes 10 to the third power of milligrams to get 1 gram, and then my units can cancel. So 1,000 milligrams is what I need. How much is each pill? 250. So I need to take 1,000 milligrams and divide it by 250 to know how many doses to take. So I need to take 4 doses. 4 doses. Okay. Let's answer that question. Next, a doctor, or wait, flu vaccine. Okay, so you get 1 liter of coronavirus vaccine. A dose of this vaccine is 2 cc's. How many people can you immunize? Not enough, apparently, for the world goes to hell in a handbasket, but we'll do the best we can. Okay, 2 cc's. Well, we got to convert liters to cubic centimeters. 1 cubic centimeter is a milliliter, and so that helps me here. So I want to go from 1 liter to cubic centimeters. So I'm actually going to have to do 2 conversions, but this is a good chance to talk about this. So we want to go from 1 liter over 1. We want to convert that into milliliters, right? And so we're going to go put milliliters on top and liters on the bottom. We know there's 1,000 milliliters in 1 liter. And then to get the next conversion, I need to go to cc's. So I'm going to put cc's on top because that's what I want to get to, and milliliters on the bottom. And then that should give me cc's. So we're 1 cc and 1 milliliter. Wow, that was easy. Okay, liters cancel. And now I got my units of cc's. So what I really have is I have 1,000 cc's of flu vaccine. Now, 1 dose is what, 2.5 or something, or 2. So 2 cc's is 1 dose. So how many doses can I get out of 1,000? 500 doses. There you go. All right. This one's kind of sad and obscure. It's you have to be 1 meter tall to ride Legoland jungle safari ride in Europe. Your son's 125 centimeters. How tall is he in meters? So convert to meters, and then can he ride the ride? Well, let's take a look. If he's 1 meter tall, dude, he's not going to Europe. Nobody can travel right now. You might be able to get into Legoland, like down at the mall. Where is that? Off the I-10 over there. Mills, Arizona Mills. He might be able to go to that Legoland, but we'll see. So anyways, we're converting 1 meter. We need to get him into centimeters. So I put that on the top, meters on the bottom. Meters cancel. Oh wait, I'm converting, sorry. Oh yeah, okay, that's fine. I can do it this way. So there's 100 centimeters, right? There's 10 to the 1, 10 to the 2 in 1 meter. And that gives me 1 meter is 100 centimeters. My son is 125 centimeters. Okay, well, he's tall enough to ride the ride, okay? But I forgot to convert this to meters, so let's go the other way. 125 centimeters multiplied by our conversion, we want to get to meters, so we put 100 on the bottom, right? That's our 10 to the 1, 10 to the 2 is 100, so we put that on the bottom, and then we get 1.25 meters. So yeah, he's tall enough to ride that ride. Okay, so take a photo of that page. And let's just do a couple of the scientific notation problems before we go. So I'm just gonna do like I'll do A and B or something for each one of those, and then we'll be done. So standard notation, I've already talked about this. Or scientific notation, I've already talked about this. If you have a number like 5,317, and we want to turn that into scientific notation, we can imagine there's a decimal point and a 0 there, and that's going to help us. So what I want to have ideally in scientific notation is I want to have one number to the left of the decimal, followed by the remaining numbers to the right of the decimal. And so my question is, well, how many places am I moving this decimal to get to where I want it, to get to where it's like that? Well, I'm moving it 1, 2, 3. Well, that means I need to multiply it 10 to the third power. It's that simple. Okay, so I'll do another one for you guys. And then we'll do a few questions. So let's say I have like 12,472. Okay. And I want to turn that into a scientific notation. I got to put a decimal and a 0. And then remember, I want to get one number to the left of the decimal and then the remaining numbers to the right. And I got to count how many times I do that. So I go 1, 2, 3, 4. 4 decimals will put it there. So I multiply that 10 to the 4th power. Okay. Let's see the problems. A couple of the problems there. So we've got 234. Well, we can imagine that's 234.0. We want it to read 2.34 times 10 to the something, right? 10 to the 1, 2 power. We'll put it there. Okay, that's the first one. The second one, we're going the opposite direction. This will be a good one to review. So 0.0037. And we want to turn this to scientific notation. Well, it's the same idea. We want it to still read one number to the left of the decimal and then the rest of the numbers after it. And I just ask, okay, how many times do I have to divide by 10 to get there? 1, 2, 3. So I multiply by 10 times the minus 3, because the minus 3 is going to move the decimal that way, plus 3 is going to move it that way, right? So we're talking about, it's the difference between a fraction or thousands and millions, right? So are we dividing it into thousands and millions of pieces, or we got thousands and millions of parts? And that's what this decimal does. Okay, next problem. So let's go to the other side. It asks us to convert 8.35 times 10 to the 4. Well, when we multiply by 10 to the 4, that's how many times we move it to the right, because that's a big number. 10 to the 4 is like 10,000. So we're multiplying 8.35 times 10,000. So we'll probably get somewhere around 83,000, I'm guessing. So let's figure this out. 1, 2, 3, 4. That's how many places to the right I'm going to move. We need 2 extra zeros there. So 8, 3, 5, 0, 0. Right, because I started here and I went 1, 2, 3, 4 places to the right with the decimal, right? 4 places to the right. That gives me 83,000. Next problem, we'll do 5.87 times 10 to the minus 3. 5.87 times 10 to the minus 3. Yeah, same idea. This time I need to say, okay, I'm dividing by I'm dividing by units of 10. So I need to go backwards 1, 2, 3 decimal places back. Fill it in. That equals 0.00587. And you can see this 10 to the minus 3 because if you go 1, 2, 3, you're back to where you started. 5.87 times 10 to the minus 3. Cool. I hope all that made sense. Good luck finishing this up. I will see you guys on the next one. Oh, this is on the floor. Okay.